Hello and welcome to this algebra lesson on solving a system of equations by substitution. Well, we have a system of equations here. There are two equations, each involve the same two variables, and the object is to solve, in other words, to find the value of x and the value of y that will make both of the equations true at the same time. Now, the last time we did substitution, we already had two equations that said y equals, and we just substituted one equation in for the other. This one requires a step first. Before you can do substitution, you really need to get one of the variables alone. And it doesn't matter which one, but when you have a system like this, you look at the coefficients. And I have a y here that has a coefficient of 1. That will be easier to isolate than something that has a coefficient in front of it, because then I'd have to divide. I won't have to divide by anything to get this y alone in the first equation. So what I tend to do is I tend to number my equations. 1 is 4x plus y equals 5. And equation 2 is 6x minus 3y equals 3. Because you do want to keep straight which one you've used already and which one you haven't. So I'm going to change equation 1 around. I'm going to make my equation 1, I'm going to isolate the y. And I'm going to do that by subtracting 4x from each side. So when I subtract 4x, what I get is y equals 5 minus 4x. I can use this instead of the original equation because it's the same relationship. Now what I have is I have this y, and I have a y in the second equation. So I look at equation 1, and I can use what y equals in equation 1 to replace the letter y in equation 2. And when I do that, this is what my new equation 2 looks like. So I still have the 6x minus 3, and instead of writing y, I'm going to use that 5 minus 4x. Now, this equation has one variable, so I can find a value for x. So I have to distribute the negative 3. I have to do this carefully. 6x, negative 3 times 5 is a negative 15. Negative 3 times a negative 4, be careful here. Two negative signs multiplied together will give me a positive 12x equals 3. Now I have to group like terms. When I have more than one x, I have to group like terms. I have a positive 6x and a positive 12x. I get 18x minus 15 equals 3. Add 15 to both sides. Add 15. That comes out nice and convenient. 18x equals 18. It won't always be convenient, but in this problem it is. So I divide both sides by 18 to get x by itself, and I get x equals 1. You say, well, that's good, but you're not done, because you have to find an x and a y. But you've already got a relationship for how to find y from x, so you use that. So you take this x equals 1, and you do y equals 5 minus 4 times 1. You replace x with 1. And you get y equals 5 minus 4, which is 1. So x equals 1, y equals 1 is what I think my solution is. Now the way you can check that is, so to check this, I put x is 1 into either equation. Actually, I should be able to put it, I should put it into both to thoroughly check. I want to see if this is true. And I get 4 times 1 plus 1, that's 5 equals 5. Yes, so it is true. So the solution to this is x is 1, y is 1. And I started by isolating the y because it just had a 1 in front of it. In the next video, I'm going to do an example of one where you isolate the x. It doesn't have to be the y you isolate. I will do one more video with an example of that in a moment, and you can email me if you have any questions.